Right, let's start with machine learning today. There are a number of things that I wanted to cover, and I think this will take about three or four. This will take about three sessions essentially. Today is just the very basic, and I'll cover the classification of machine learning. I'll try to touch upon data science as well, and basically I'll try to relate data science with machine learning. That is one of the things I'll do. Okay, so I've already understood the audience. Now I'll just walk you through one slide which I've already covered in the very first session. So what is data science? We are trying to solve problems using data, and we are using some tools. For example, Python, we've already studied Python. Even Excel helps us with this, or other tools like R, and then other languages. So all of these help us to solve problems using data. And what is the purpose? We want to formulate strategies. We want to build something which can help people take a decision. So the upper level of companies, the management level of companies, we want them, the leaders of the companies, to take decisions, and we want them to want to give them a strong reason for backing their decisions, right? So that reason can be given through data science. That reason will be provided to them through machine learning models, essentially. So I've already told you the steps in data science. Now, instead of me walking you through what is data science, I want you people to tell me each of these steps. So first is mining or collection. Mining and collection. So these are essentially different things. Let me know what you mean by mining or collection. Any out of those. Tell me what you understand from this, because I have covered this.
Accumulating the data from all sources.
Correct. Yes. So getting the data, or in some sense collecting the data from online or offline sources, right? Okay. Any other definition, or any other thing you want me to cover here? Like you are thinking that we should touch upon any other thing within mining or collection, or
Raw
I'm
data,
right?
raw.
Perfect. This was the keyword I was looking for. There's one more keyword actually, but this is definitely one keyword I was looking for. So this is basically raw data. We are trying to get raw data. Now the data is in this format as of now, and we are just collecting that from Facebook, Twitter, any social media platform, or even any government website, any kind of website, or even offline sources. What can be an offline source? Give me an example of an offline source of collecting data.
Forms,
Form is an online
Survey,
source.
Always.
surveys.
Yes, survey is an offline source. Um, Customer interviews is a very famous method of collecting data offline, which essentially means that I am trying to talk to people and trying to get their understanding of the problem, or getting data from them. What is your name? What is your age? What are the diseases that you've faced in the past? Do you have any difficulty in walking? Right. This was a survey that I conducted last year, and I talked to old people of about 55 plus years of age or 60 plus years of age, and I collected this data almost entirely through offline sources of data collection, which one of which was surveys, another was this offline interviews, talking to people, mostly communication, right? So that is the first step. We are done with this. What is this step? Cleaning. I want one more word for this. Cleaning is a very straightforward word, right? I want one word in data science.
sorting,
Sorting, see, don't see this and tell me, but yeah, I mean, sorting is correct. See, yes, okay, sorting is correct, but we are not, so we might not sort the data. There might be more to it, right? So the correct word that I was looking for, I have not really got that word as of now. But munging is
Filtering.
also a correct word. Munging is a correct word. So data munging is essentially cleaning the data and trying to convert the data into trying to convert the raw data, mind you, because this is the raw data that we've got, trying to convert it into a more usable format, because our machine learning models are very standardized. They use very standard types of data formats, right? Say, for example, a data table, Excel format, all of that. One more word for this: data cleaning. Um, Data cleaning is a, so basically it's not very widely used in data science. The word that we use here is data wrangling. Have you guys heard of this word, wrangling? Now this is where we try to clean the data. We try to pre-process it, or this is essentially a combination of parts of these three. But essentially, we are only talking about cleaning here, mainly cleaning, and then trying to convert it into a usable format. That is wrangling. Uh, by the way, this is also a question that I've given in one of your assignments. But yes, what is pre-processing? Let's move to the next step. Cleaning is done. What is data pre-processing?
Converting it
Like
to a
integration
required
of data.
format like NumPy array or list or something.
Right. That is correct. Yes. So essentially, when we get the data, we are trying to convert it into convert it into a usable format. One more word again for pre-processing, like one of the keywords of the definition of pre-processing. Any guesses? Okay, so the word I'm looking for is manipulation of data, right? Here we try to manipulate the data. Let me give you an example. Suppose you want to, suppose there are some of your values, some of the values in your data set are missing. You want to take some action for those on those values, right? Because you want a complete data set. You don't want a data set with some values missing and there's some data randomly um, placed in the data set. So that is not what you want. So when you have some values missing, you may, there are a number of techniques that you can follow. One is that you can simply remove those rows, right? Or another is that you can probably fill NA there. This is a common practice. So we fill NA there so that there's something there and the computations that we do on the data set are easier, right? What is the next step? Exploration and visualization. Again, tools to use here. What can be? Tell me five tools. Tell me four tools, right?
Matplotlib, Seaborn.
Seaborn.
So these are libraries within Python, right? So let's call Python as one tool. Python is one tool, and the libraries that we are talking about are Matplotlib and Python. Now let me bring you back to that session where I talked about these libraries. So when we talk about visualization, we are talking about Matplotlib, Seaborn, and Plotly is another library. This helps you build 3D graphs also. So this is also very good, and this is very interactive that way. So Plotly is also a good library. Most commonly used are Matplotlib and Seaborn. Where does the mat come from in Matplotlib?
MATLAB.
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 Perfect. So let's start with the other. Let's touch upon the other ones also. Python is one visualization tool. Tell me some more visualization tools.
Tableau.
Tableau is one. Yes. If you don't know these tools, we'll study them
MATLAB is
deeply.
also one.
Okay, MATLAB is also one. So
Excel.
Tableau
R.
and Power BI is also
R.
is also
R.
a good tool. Yes, R is also a tool.
Excel also, right?
Excel is also there. Yes. So all these are tools for data visualization and exploration. Next, we have transformation, and this is where we sometimes use machine learning also. Suppose we have 10 features. What do I mean by features? These essentially explain the data, right? Suppose I have your marks. Suppose I have a student database in which I have marks of a student. That is one column. Then corresponding to each student, I also have the grade for each student. Then I have the gender, the address of the student, 10th marks, 12th marks, all of these. So all of these columns are features basically, and these help explain the academic record of the student, right? Address does not and gender does not explain the academic record, but let's say I have similar features which explain academic record. So these features are these are 10 features, let's say. Now I want to reduce the number of features because I don't want to make my machine learning model very complex. So what can I do? I can probably use data transformation. I can probably combine two or three features together in order to get one single feature which is more useful than each of the three features individually, right? So that is where we talk about transformation. So one technique that can be used here is PCA, principal component analysis. I think we'll cover this in the next or the next to next session. Then post that we have modeling. This is where we build the machine learning model, and this is where the AI engineers, machine learning engineers, or even statisticians, these people come in. And finally, we build this house, this beautiful house, so that we can convey some message to the top leadership of the company or to the professors or anyone. Basically, we derive insights from data. That is the final step. Now, where does machine learning come in? Why have I touched upon data science first and then why have I moved on to ML later? So basically, in this process of data science, right, machine learning comes in here. And when we talk about machine learning, we know for a fact that there's some relation to artificial intelligence. This everyone knows, this everyone has heard of, that we are trying to use data to make some kind of decisions, to take decisions or predict something, classify something, do some computation. We are trying to use data. Then we are using algorithms. That is for sure. And the model itself learns progressively. So this is why it is known as machine learning, because the machine itself learns progressively. So that is learning progressively. So as we build the model, as the model gets used more and more, the accuracy of the model improves. What does this mean? This means that the model predicts better or the model performs better, right? Now, two very famous use cases of machine learning are prediction and classification. Now, these are most commonly used use cases of machine learning. So, machine learning is mostly used to predict something. Say, for example, what is the weather tomorrow, the temperature tomorrow. So, that is where machine learning can be used, or classification. Suppose I feed 10 images to my machine learning model. I want the model to classify them into groups of let's say fruits, mangoes and apples. So I want the model to classify separately, uh, classify the images into distinct classes. That is classification. So I'm trying to classify. More on this late in later slides, so don't need to worry if you're not understood. Since I was talking about defining ML, I'll now formally define machine learning. So it is a branch of AI and computer science which focuses on the use of data and algorithms to imitate the way that humans learn. And essentially, this is a process that is trying to imitate the way humans learn, right? This is artificial intelligence. So this is something that is relating to the working of a human brain. And we are trying to gradually improve its accuracy. So the model improves its accuracy as it gets trained again and again. Um then other definitions are similar. It gives computers the capability to learn without being explicitly programmed. We are not explicitly programming it. We are not telling it that this is a cat and this is a dog. We are essentially leaving the model to predict on its own, to classify on its own. So the model is taking its own decisions. We train it once and then leave it. It will give the results on newer data sets on its own, right? Then we have, so if we talk about definitions, I'll also take up some definitions by famous universities and companies. So, say for example, Stanford has defined machine learning as the science of getting computers to act without being explicitly programmed. So, we are not explicitly programming computers. We are essentially training them, and then they take the decisions on their own. Similarly, McKinsey has defined it as based on algorithms that can learn from data without relying on rules-based programming. So this is different from the programming, competitive programming that you do, right? That is based on rules. This is not based on rules. You define something once, and then the model itself takes decisions later on. Now let's move to some technical stuff. How does machine learning work? Now, are there any questions till now?
No, sir.
Uh, okay, so there was one question I missed. Isn't customer interview a lengthy process? Yes, it is a lengthy process and depends on, sometimes the interviews might take 1 hour. In product management, interviews take very long. But essentially, if you want to get data, then this is one way to get data. So you might even have shorter customer interviews. This is probably not the most effective way to get data, but yes, it is one way. So how does machine learning work? There are three parts to machine learning processes, right? First one is a decision process. This is the part where machines are taking some decisions, right? Essentially, machines essentially we train the machines to take a decision, and these are the process that is involved here is essentially an algorithm. So an algorithm guides the machine how to take the decision. And in general, what are the two use cases, two most important uses, or why is the machine learning algorithm used? Mostly it is either used to predict something or to classify something. That is essentially uh, prediction and classification are essentially two use cases. So I'll explain. I'll give more examples of each of these later. Now, let me tell you one important classification within machine learning. Let's take the example of images of cats and dogs, right? Let's take 100 images. There are 72 images of cats and there are 28 images of dogs. So I know for a fact that there are 28 and 72 is the split of images of cats and dogs. I'll feed that to the data set. Now suppose the image has a label along with it, that whether it is a cat or is it a dog. So that label, if I have the label along with the image and provide it to the machine learning algorithm, that is labeled data. And this is a very important question, interview question also. So label data essentially is when you have the label along with the data, that when you have the label along with the information that you are providing to the machine learning algorithm. So in case of an image, you need to have a label of the image itself. The other thing is unlabeled data. Suppose I simply directly feed the data to the machine learning algorithm that these are 100 images and I don't tell anything else to the machine learning algorithm. The algorithm at this point does not know whether it is a cat or a dog or whether it is an animal at all or anything, right? It doesn't know anything of that sort. It just sees those 100 images. That is all. That case is the case of unlabeled data, right? So labeled data and unlabeled data. We have the tag or the label of the data along with it, that is labeled data. Otherwise it is unlabeled data. So based on some input data which can be labeled or unlabeled, the algorithm will produce an estimate about a pattern in the data. So it will try to identify a pattern in the data, right? And this pattern will help you to predict something. A very famous example, Boston is in the United States. So there is this famous Boston house prices data set. In the data set, there are prices of houses in this Boston area, right? So I think it's a huge data set, and there are lots of data points. Essentially, there are lots of points of data, right? And that is where we talk about prediction. Suppose I want to predict the price of a house next year. right? It has the data corresponding to 2020 and 21, 2 years, let's say. And I want to predict the price of house in 2022. So what it will do is it will take the data that it has of 2020 and 21. It will have try to bring out some pattern or a trend from that data, and based on that pattern or based on that trend, it will identify, it will try to predict something in the future. That is prediction. So suppose I take the example of prices of houses in Delhi. So I have data corresponding to 2020, and I want or 2022, let's say. I want to predict the price of a house on 1st of January 2023. That is where I'll talk about prediction. So that is a machine learning model that is going to be used, and it will try to predict the data. So let me draw a simple graph here. Let's say these are let's say this on the y-axis is my temperature, on the x-axis is the time. So let's say this is 2023, 1st of January of next year, and let's say this is the price of each house in of the houses in Delhi in 2022. So let's say I am almost at the end of this year, and I'm trying to predict something on the first date of the next year. So suppose the temperature values are such that this is the kind of distribution that we are seeing. So there's a gradual increasing trend, right? The prices are increasing gradually, and there's of course some variation because of some COVID or something. Prices decreased at some point, then again they increased. If I draw a line that tries to regress on this, right? If I draw a line that tries to explain the trend, then it will be something like this. And that line will help me to predict the price of a house in 2023, right? This is what is called so first of all, this is machine learning. We are trying to bring out some pattern from the data that we have, and we are trying to predict something. So this is a use case of prediction. Second is, this is known as linear regression. We are trying to regress linearly. That is linear regression. I've already I think I've mentioned this term before also. So this is linear regression. Now this is the first part of the process. Second is an error function, which is very easy. We're just trying to find out the error of prediction. Let's say the temperature. So we are trying to predict the temperature, right? So the temperature is 22 degrees Celsius, and so this is the temperature that this model has predicted, right? So this is the temperature that the model has predicted, and the actual temperature is, let's say, 23 degrees Celsius. So there is an error. The actual temperature, let's say, we are in we are in January of 2023, and the day has already passed. Now we can see that there was an error in my prediction. So we know the actual value also, and we know the predicted value also. So there is an error of 1 degree, and whatever percentage that can be calculated. So that percentage error, the function which calculates this error is the error function. And what is the purpose of calculating the error? We want to minimize the error, right? We want the prediction to be more accurate. The model should perform better. That is the purpose. So this is why the error function is calculated. Now, what is the end goal? The end goal is to predict something, and we want the prediction to be very accurate. For that, we define a model optimization process, which tries to improve the model in such a way that the error reduces, or the accuracy improves. The accuracy of prediction improves, right? So that is a model optimization process. So we try to adjust the weights. You don't need to know about weights as of now. So just know that there is some kind of optimization. The model tries to improve based on some process. So that is a model optimization process. Um, and the algorithm will repeat this evaluate and optimize process. It will first evaluate, and then it will optimize. So it will keep on doing this again and again until the accuracy improves, right? So suppose the accuracy was 80% earlier, then after some training cycles, it improves to 90%. And after a certain point, the accuracy does not improve further. It's constant, like 98%, 99%, something like that. Then that is an example when a threshold is met, a threshold of accuracy is met. So that is a model optimization process. Let's move away from technical part a bit, because I'm sure it might not be very easy to digest this in the first bit. So let's see what the distinction between ML, AL, AI, and DL is. So AI is, of course, a very big field. It was there it was there, I think, even in 1960s, 1970s as well, even before computers were there, because this is a theoretical thing. AI and ML are theoretical processes, right? Only after the computation power increased because of IBM, Google, and so on, only after that were people able to really realize the power of machine learning. So essentially, AI is a big field. It is a technique which enables machines to mimic human behavior. And machine learning is a subset of AI which uses maths and stats to enable machines to improve with experience. And deep learning is again a subfield of machine learning. And what is specific for deep learning, what is the characteristic of deep learning is that it tries to replicate the neural network in the brain. So we are not bio students, of course, but we know for a fact that there are neurons in our brain, which there's a neural network which helps us to make decisions. So signals are transmitted to this neural network and we make some decisions. And that is exactly what deep learning is trying to replicate. Uh, that is exactly what deep learning tries to do. So it makes the computation of multi-layer neural network feasible. So neural network, it tries to make a neural network, and there are multiple layers of this neural network, and each of these layers helps us to compute something, right? Suppose I'll again take the example of predicting the prices of houses in Delhi. Now, that prediction might be accurate. Suppose I add another layer. Suppose I add another layer of neurons to my model. It will make the prediction even more accurate, right? So this is where we talk about neural networks. Deep learning is all about neural networks. So, and this is a somewhat advanced field of machine learning, which is not difficult at all. It just requires some theoretical understanding of neural networks and some idea of the maths behind machine learning.